I'm going to say it, the .NET framework sucks for machine learning. Any sort of neural networking type activity, people just jump straight to Python. If only there were some great library for .NET framework that could let us make these neural networks. Oh yeah, that's right! The Hype library, made by the guys at the University of Ireland, Maynooth, is great for any of these sort of neural networking type tasks. It even supports LSTMs, long short-term memory networks. I'm Wes, welcome to .NET Paradise. Hype is a machine learning framework that I actually stumbled upon by accident while I was learning how to program in F#. It's great because it supports all of the really cool sort of theoretical neural networks that just haven't made it into mainstream .NET programming yet. My favorite is the Long Short-Term Memory Network, or LSTM, and that's what this video is going to be about. Today we're going to teach you how to make an LSTM in F# with only a few lines of code. So this is the Hype page, the link is in the description. So go ahead and take a look at their webpage if you want any more information or if you want to support them in their project. In this video, I'm going to be walking you through the recurrent neural networks page that they have on their website. This leads to a really great working LSTM. I even tried feeding it some of my school homework and seeing if it could generate some of the answers for me, and it did all right. It wouldn't have been usable to a human eye, but it might have passed a machine-based check or something like that. The problem with these long short-term memory networks is that if they have too much data, it can take them quite a while to train. So we're just going to be going off the default sample data that they provide for us on the website. Here I have a new F# project with a few imports and a little thing at the bottom here so we can use the console without fear. And the first thing we're going to do is install the Hype library. Now this is actually quite easy because it is being maintained as a NuGet package. So what we can do is just project, manage NuGet packages, browse for Hype, and install it there. I've already gone ahead and installed it along with its dependencies just to speed up the video a little bit. Now there's one major problem with the Hype library that I've gone through the forums and I've seen that there are quite a few people frustrated with it, and there's actually quite a simple solution. The problem is the moment you try and use the Hype library or any of its dependencies, which I encourage you to pause and copy down, it throws errors. It just doesn't work. And the problem is it has to be running in 64-bit mode just because of how it's set up. So what we're going to do is hit the drop down and go to the configuration manager, make a new one that's just x64, and OK that. Now it will run as a 64-bit application, and we won't have to worry about the bad image exceptions getting thrown. So first thing we're going to do is I'm going to paste in my sample text, which in this case is a selection from the opening of Book 1 of Virgil's Aeneid, which is, again, just the sample text used on the website. And if we need to use this text to train our network, we have to turn it into something that the Hype team calls a language. And all this is it is a mapping framework that allows you to turn any of these tokens, any of these substrings or these punctuation marks or anything like that, into a one-hot vector, which is just simply a vector with 1, 1, and everything else 0. To that end, the Hype team has been generous enough to implement a new object type for us called a language, which we can construct quite simply, actually. I'm going to make a new variable and call it lang, and I'm simply going to pass the text that we'd like to train and run off of into the language constructor. And voila, we already have our encoding scheme. And actually, there's a pretty nice print function built into this. So if I print out the tokens by piping them through a printfn of %a, because it's a list, we can actually see how it breaks down this text into tokens for us. And if you can see, each item in this array, is going to be an individual token from our text. Cool. Now that we have that, we can encode it into the actual vectors that our network is going to run off of. So what I'm going to do is make a new variable. I'm just going to call it text prime because it's been encoded. And we're going to use our lang variable to encode into one-hot vectors the source text. Simple as that. We now have all of our one-hot vectors. Now, in order to train it, we need to give it both inputs and outputs. In this case, what we want it to do is, given a token, a word, we want it to be able to predict the next word in the sequence. So what we're going to do is we're going to make a new data set, which we're going to just call data, and I'm going to just copy and paste this off the website for the sake of accuracy. And here we go. What we've done here is we are making a data set of this slice of text for the input, so we're dropping the last character, and this slice for the output, where we're dropping the first character. And that way, the first character will map to the second character, and the second character will map to the third character, and so on and so on. So this way we can get it to sort of, guess the next thing in the sequence. Now, we need to make a variable with the size of our data set, just so that when we're creating our layers of our network in a second, we have the dimensions for our input and our output. So I'm going to call it dim. Sorry, VB programmers, that's probably irritating to you. And we are going to make it so that these one-hot vectors, which are by definition going to have one and everything else being zeros, the size of these, the way this language framework is built, is going to be the number of tokens. That way you just have one index for each token. Makes things nice and simple. So our dimension is simply going to be the length of the number of tokens in our language. So it's just going to be lang.length. Now for the fun part, we get to make our network. I'm going to call mine NN for neural network, and we're going to do this as a feed-forward network. And we are going to add, first of all, a linear network, which allows us to crush all of this input, the dimensions number of input, into simply 20 nodes. And then we're going to add the main portion of our network, the LSTM itself. Oops, if I could spell. Isn't that simple? We created a whole LSTM with just that. Now we're going to add another linear network, just so that we can unpack that output into the full one-hot vector scale, so we can reverse it back into the actual tokens themselves. Sorry, I was a bit distracted there. Last of all, we are going to add a dimension matrix, which is a nice little feature that they added in for us to do things with large numbers of numbers. And we're going to tell it to use a softmax classifier. You can look that up on Wikipedia if you'd like to know what that is. I'll post a link in the description. Great, easy as that. And if we wanted to add another LSTM, we could simply just, tell it to be another layer. As simple as that. You can stack them indefinitely, which is really nice. A really nice thing that this framework supports. Stackable networks. Now, we're going to reset all the values in our network to get a nice base state for it to work on. And we're going to make a new variable called I inside of a loop, and we're going to iterate from 0 to 5, doing our training. So, first of all, I'm going to have it just print out some of the random junk so you guys can see what it does. And we're going to tell our language to sample, which means take the series of vectors and convert it back into the strings for us. nn.run, so run the network. Starting with the character I, or sorry, the token I. Make sure that's a token, not a character. Then we need to give it our stop array, and what that means is it needs a list of things to signal the end of the data. So in this case, what we're going to do is we're going to tell it the moment you get a a full stop, a period, stop. Just stop sampling. And then this 30 at the end means also if you hit 30 characters, stop sampling. And we're just going to pipe that into a printfn of string. There we go. Now when we run this, it will generate the network for us, and it will give us 6 samples of things that it will spit out just randomly. Notice the first character, or the first token here, sorry, is always I, because that's what we told it to make the first token. So if you're wondering why there's that repetition in there, that's why. Now let's actually build in our training logic. So I'm going to replace this by saying I from 0 to 1,000. 1,000 sounds like a good number of training steps to do. And we are going to, outside of this for loop, we're going to set up our training parameters. In the online tutorial, they have the parameter inside of the loop. However, the parameters don't change, so I've just refactored it outside of the loop to save us a bit of execution time. And we're going to set this up to the params.default, which is a nice little pre-baked thing they have for us. And we're just going to modify a few of the values here. First of all, we're going to set our learning rate equal to an RMS prop. Again, link to a Wikipedia article in the description. And we're going to give it a value of 0.01 and what I believe is a momentum value actually of 0.9f. I could be wrong on that, but I believe it's training step size and momentum. That's my guess. Next up, we need to give it our loss function. Neural networks require these loss functions so they can figure out how much they need to change, because there's no real point in trying to train a neural network if you're not telling it how far off it is. And we're going to use a cross entropy on softmax loss function. Epochs, so number of times to run per time that we call it, we're just going to do 1 so that we can get some manual control over that. Here's an important line here. Silent equals true. By default, it pumps out a lot of data each time you try and train it, and if we're training it 1,001 times, that's going to clutter up our screen very quickly. So we'll deal with the output processing ourselves. And lastly is return best equals false. This unduly slows down the network if we leave it true. So while it's useful in some cases, this isn't one of those. Great, we have our network now. So what we're going to do is we are going to make a new we're going to make a function call that returns a tuple. So we're going to only take the first value out of that. So we're going to disregard the second value. And it's going to be equivalent to layer.train. Layer being, again, one of the nice little convenience classes they added for us. NN for our neural network. The data set to train it on. And our parameters. Love variables. Great. Now we can just print out the results. So printfn, and our format string is going to be epoch number percent star I, so that we can mess with that in a second. We're going to print out the loss amount. Sorry, I keep staring over there. I've just got the page open over there. And the actual sample itself, so we can get an idea of the gory details of the inner guts and workings of this network. Cool. So our first one is going to be, we're only going to print it out to 3 digits. And we have an I, so our iteration number is where we're going to print out the epoch number, so the training epoch number. The actual loss data that we unpacked from the training, as well as, this is going to be a big one, so I'm going to bracket it off, our lang.sample, and you can probably guess what comes next, nn.run of I, our stop character of that dot, and our maximum length. Simple as that. And this is actually the full program. Look at this. The only actual code for the entire training is just this one line. We're creating the entire network with these 5. And the rest of it is things like our data and encoding it, and obviously our import statements, and the parameters for the training. So this is really simple. I tried to re-implement this in C#, not using the library, but from scratch. I'm still working on it, and so far I have several thousand lines of code. So something this simple is really a godsend for anybody who wants to have quick machine learning at their hands. And just to give you an idea of what this should look like when you run it all, assuming I typed in everything correctly, when we run this and full screen it, we have the number, the epoch number, so the iteration that it's currently on, the result of the loss function, and a sample of the output data. When I first found this this network, I actually just sat here and watched this for some way too long number of hours, just because it's really interesting to watch how it grows and how it improves. So what I'm going to do now is I am going to cut to the ending scene, and after I let the ending scene go for a little while, I'll put at the very end of the video a little sample of what it'll look like when we've given it some more time to train. As always, I'm Wes, this has been .NET Paradise. Thanks for watching, see you in the next video.